Okay, so our lesson today is pretty short. We are going to talk about domain and range. We started this unit doing domain and range. However, it's whenever we had arrows at the end of our parabola. Okay? At the end of our quadratic, we had arrows. So our domain was all real numbers. These don't have arrows, so my domain's not going to be all real numbers. When we did our range, we just found the bottom or the top, and there was only one bound because the other side had arrows. There wasn't a second bound. These are going to have endpoints. So they're going to have a left bound and a right bound, a bottom bound, and a top bound. Okay? We have already written domain and range from functions or graphs that look like these. Okay? But my guess is we don't necessarily all remember, and it's always good just to practice. Okay? And I'm frozen. So, when we have endpoints, notice that's an endpoint and that's an endpoint. When we find domain, what variable is domain? X. So anytime I see domain, I'm going to put an X above it. What type of function is this, guys? Is this continuous or discrete? Why is it continuous? Because it's what? It's connected. Remember, continue, connect, discrete, dots. So if it's continuous, this is whenever we use our inequalities, okay? Domain is X. Notice how the x-axis is labeled, okay? So that's your side-to-side axis. So I'm going to draw a line at my left bound, the left of my graph, and I'm going to draw a line at my right bound, the right side of my graph. We all agree that the graph exists in between those two lines I just drew. The whole entire graph, the parabola, exists in between those two lines. This is my small bound, this is my bigger bound, okay? So when we do domain, we're looking at X. Where does this left line hit the x-axis? -2. Where's this right line hit the x-axis? 7. So all of my x values are in between -2 and 7, okay? Do we remember doing this? I think this was like in our second unit, okay? And we've done it on warm-ups as well. Whenever we write our domain for our continuous functions, it's small to big. So -2. All small numbers are what compared to big numbers? Less than. What kind of dot do I have at -2? Do I put the equal to if it's an open dot? No. Okay? You don't see the added ink inside the circle, so don't add ink under the inequality. Okay? What variable is domain? X. Again, we need another less than sign. And what's the big number? 7. What kind of dot, though, do I have at 7? Closed dot. So I do put the equal to on the 7 inequality. Okay, so this is saying my x values can be any number that's bigger than -2 or less than or equal to 7. Okay, so in between -2 and 7, including 7. That's why I put the equal to on the 7. Good with that? Again, the first day, Ms. Polliott told y'all, or I guess Mr. Barker taught y'all, that your domain for quadratics is always all real numbers. That's when there's arrows. Here I have endpoints, so it doesn't go on forever, so it's not all real numbers. Okay, do we see the difference? Okay, range is what variable? Y. Well, look, your y-axis is labeled. That's your up and down axis. So I need to find the bottom, draw a line at the bottom, and I need to find the top and draw a line at the top. So my bottom is down here, and my top is up here. Where does this bottom line hit the y-axis? -8, because we're below the origin. okay? Where's this line hit the y-axis? This one's kind of tricky. 0. We go with that? All of my y values exist in between -8 and 0. Good? Okay, so again, just like when we do domain, we go small to big for range. What's the smaller number? So -8 is less than. Does it actually get down to -8, or do I have an open circle at -8? It gets down there, okay? It does not have an open circle, so I'm going to put the equal to. What variable am I using since we're doing range? Y. Less than, what's the top number? 0. Now this is where it's a little tricky, because look, there's 2 dots at 0, right? You have your left dot at 0 and your right dot at 0. Both of those have a y value of 0. This one's an open dot, so I want to include 0. This one, though, has a closed dot, so I would include 0. So at this point, we're including 0. So in my range, do I need to include 0? Yes. A closed dot trumps, or is more powerful than an open dot. Okay, so if you have an open dot and a closed dot at the same y value or the same x value, the closed dot is going to be more powerful, so we're going to put the equal to under it. Okay? Is this coming back to us a little bit? Good practice? Okay, next one, domain is x. Guys, I want y'all to get in the habit of every time you see the word domain, what do you put? X, okay? That's what half the battle is, knowing that domain is x and range is y. Okay, domain is x. Look at your x-axis. It's side to side, so I need to draw a left side and a right side. Left side and right side. Does my whole graph exist in between those 2 lines? Yep. Where's this left line at? -4. Where's this right line at? Where's? That's the y value. The y is at 2. The x is at 1. Okay, so again, small to big. Whether it's discrete or continuous, we always do domain and range small to big. -4 less than, what kind of dot do I have at -4? So I put equal to x, because we're doing domain, less than 1. Do I put the equal to on 1? No, because I have an open dot at 1. Good with my domain? Is it okay that 1 has an equal to and 1 doesn't? Yes, because they're 2 different values. It's talking about we're including -4, but not 1. That's okay. Range is what variable? Y. Draw a line at the bottom. Now, sometimes whenever they're not the same height, like my 2 endpoints aren't at the same height, we get confused. Which one do I choose? Do I choose this endpoint or this endpoint? So we want the very bottom and the very top. So which endpoint are you going to choose? The top one. So I'm not going to choose that one because that's not the very top of my graph. If I cut my graph off there, I'd be cutting off part of my graph. But if I cut my graph off here and here, does the whole graph exist in between my lines? Yes, I didn't lose any of the graph. Where's this bottom line hit? -7. Where's the top line hit? 2. Small to big. So how am I going to write my range? Do I put the equal to on it? Do I have an open dot at -7? No, there's no open dot there, so do I put the equal to? Yes. The only time you don't put the equal to is arrows and open dots. What variable, since we're doing range? Y. Less than, where's my top? 2. What kind of dot do you have at 2? Open, so do I put the equal to? No. Good? Okay, last one of these, guys. Domain is x. Your x-axis is side to side. Draw a line at the left. Draw a line at the right. Where's the left line hit the x-axis? -3. Where's the right line hit the x-axis? 2. So it's -3 less than, do I put an equal to? Yes, because there's a closed dot. What variable? X less than 2. Do I put an equal to under the inequality with the 2? No, because the 2 has a open dot. Good? Okay, range is y. Y is your up and down, so I need a line at the bottom and a line at the top. Line at the bottom, line at the top. So where's the bottom line hitting the y-axis? -7. Where's the top line hitting the y-axis? 2. So -7 less than, do I put an equal to line? Yes, because there's not an open dot. Y less than, what's the top number? 2. Do I put an equal to line? Yes. Good? How do we feel? Good? Bad? Okay. We're still going to do, bless you, domain and range, but now we're going to do it from a table, okay? Whenever we have a table, we need to first identify what type of function this is, okay? Guys, what unit are we in? So they're probably going to be a quadratic. How do you identify if a table is a quadratic? What do you think? How do you find the vertex on the table, though? That's true, but how do you find the vertex on the table? It's being sandwiched by pairs of y values. It's the only y value that doesn't have a pair. Now looking here, though, does 41 have a y value that matches? No, but is -441 your vertex? No, because that's not being sandwiched by pairs of y values that match. So you need to look for y values that match. 1 and 1, are those the same? This is going to help you on your quiz, guys, so I'd make sure I'm paying attention. 1 and 1 match? Yes, go in. -7, -7 match. So what's my vertex? -8. There is your vertex. If you have a vertex, you are what type of function? What unit are we in? Quadratics. Okay. If I have a table, do I see endpoints? No. So what is my domain for all quadratic functions that don't have endpoints? All real numbers. So my domain is going to be all real numbers. Okay. Now your range, we don't need an upper bound and a lower bound because we don't have endpoints. There's only a bottom or a top, depending on if your vertex is a min or a max. So we need to determine, is my vertex a min or a max? Okay? Look at your, and y'all did this a little bit on your homework. Look at that -8. Is -8 the biggest or the smallest y value on the table? So -8's the smallest, meaning that your vertex is a small minimum. So this is a minimum. It helps if I can spell. Min, mum. Is that right? I don't look right. Is that right, though? People that are better spellers than me? Okay. Okay, so there's only one bound. When you only have one bound, I'm going to use my y. If it's a minimum, that's a bottom. So all the y values are that's not a negative. 41's positive. But bigger or smaller? They're all bigger. If you have a minimum, that's the bottom. So all the y values are bigger. All of these y values are bigger than -8. So what do you think my inequality sign should be? They're bigger, greater than. Do I actually have a y value of -8 on the table? Yeah, so what do I need to put under the inequality? equal to. And what's the y value of the vertex? -8. So this is more like the domain and range that we wrote on the first day, okay? It's just from a table instead of from a graph, okay? We go with that? You did this again, you didn't do domain and range, but you had to identify if it was a min or a max on your homework, okay? Next one. Do I see pairs of y values that match? Yes. Match, match. Where's my vertex? -1, -8. So if that is your vertex, I'm a quadratic. Meaning my domain is what? All real numbers. Now I need to determine if that vertex is a min or a max. We're going to look at the y value. Is 8 the biggest number or the smallest number on the table? It's the biggest. So if 8's the biggest, is that a min or a max? That's a max. Max means big. So this is a max. So that means y. If that's the max, if that's the biggest, all the other y values must be less than. They must be smaller. You can't be bigger than the max. The max is the biggest. So everything has to be smaller. Do you actually have a y value of 8? Yeah, so I'm going to put the equal to 8. We good with that? Okay. We're going to do one more thing today. Quadratic regression. This should be pretty easy. We've already done linear regression on the calculator. We've already done exponential regression on the calculator. We are now doing quadratic regression. When you do linear, quadratic, and exponential regression, all of your steps are exactly the same, except whenever you get down to the arrow over to calc, you have to make sure you choose the right regression. There's one that says linreg, there's one that says expreg for exponential regression, and then there's one that says quadreg for quadratic regression. How do you know when to choose which regression? It's always going to tell you. Based on the table, write a quadratic equation. So I'm going to use quadratic regression. Okay? So, before we even do these calculator steps, does anybody remember what we should do first when we put stuff into our stat? Restart it, clear the memory. Guys, we all want to do this with me, so let's sit up. This is like the easiest thing in the world because the calculator literally gives you the answers if you know how to put it in the calculator. Will you have a question like this on your test? Yep. Am I going to help you? Nope. Okay, so let's make sure we're practicing with me. How do I clear the memory? Perfect. Second plus 712. RAM cleared. Second, which is your blue button, plus sign 712. Then we're going to follow our steps. Go to stat. Hit. It's already on edit. It's already on edit, so I'm just going to hit enter. Then it says enter the X values into L1. Remember, guys, I've said use your pointer finger to keep track, because if you don't put the numbers in correctly, it's not going to give you the right answer. So 5, enter. Also, you go a lot faster whenever you're actually using your pointer finger to keep track. Then you're going to arrow over and put your y values, your height values, into L2. You don't need to put the comma. Remember a couple of things to make sure you put it in correctly. Your L1 column and your L2 column should always be the same length. If you have more data in your L1 column or more data in your L2 column, you did something wrong. Okay, you either wrote / typed something in too many times or you skipped over a number. Okay? So Thomas, clear your calculator. and then we're just doing quadratic regression like we did our linear and our exponential regression. So that's where we just follow these steps. Go to stat, hit enter, put your x values in L1 and your y values in L2. You good? Okay, so then it says, hit stat again. Arrow over to calc. So hit the arrow over, calc is highlighted. Again, this is the same exact steps for all three of our functions regressions. This now is where it's a little bit different. You would choose whatever regression it's telling you to write that function's equation of. This says a quadratic equation. So we're going to go down, be careful, there's one that's also called quartic. Okay, that looks pretty close to quadratic, so be very careful when we're not choosing 7, we're choosing 5. Quad reg. Good? And then this is where we hit enter, and then you just hit enter a bunch of times until it goes down to calculate. And then you hit enter. Voila, it gives us our answer magically. Okay? You need to make sure you round the correct way. It's always going to tell you. This says nearest hundredth. How many numbers after the decimal is 100th? 2 numbers after decimal. Okay, so looking at my calculator, what's the A value? -4 Remember, when you're rounding to 2 numbers, you need to look at the third number. The third number's a 9. 9s round things up. What's in front of the 9? What's in front of that third 9? A 9. So if you round a 9 up, it becomes a 10, so the 8's going to become a 9. Your 89, look at that as like an 89. Your 89 is going to become a 90, okay? So -4.90. Your B is 294. Again, look at the third number. The third number is a 1. Does 1 round things up? Nope. So it's just 96. And then C, look at your third number. My third number again is a 1. Does the 1 round it up? Nope. So then it's just 0.57. Guys, if you have an A, a B, and a C, what form do you think we're writing this in? Standard form. And also, guys, the great thing about the calculator when we do our regression is it tells you the equation, the format to put it in. It says the equation is y equals ax squared plus bx plus c. So that's the format you're writing your answer in. Y equals A, which is -4.9. Do I need the 0? No. X squared plus B x plus c. What is this equation then used for, guys? Do we remember what our regression equations are used for? If I were to put this equation in my y equals and pulled up the table, would these be the exact values? They would be the exact real-world data and exact functions, we think? No, it's a rough estimate, okay? But we use our regression equation to make predictions, okay? If we wanted to know what the projectile height is after 50 seconds, I could plug 50 in for x and find y, the height, okay? We good? We ready to do one more? And then we're done with notes. Short day. Okay, what should I always do first? Clear the calculator. Second, plus 7, 1, 2. Then go to Stat, Edit. Your size is your X value. Then the cost is your Y value. Bless you. Okay, what do I do after I put my data in? Press what? Stat. And then calc. And it tells me again, write the quadratic equation. So I'm going to choose quadratic regression. And there we go. What's my A? Okay, so look at your three numbers. Does 9 round things up? What's in front of the 9? So it's going to be 2.01. And then B is, does a 5 round stuff up? Yeah, so my 89 is going to round up to 90. So 1.9. And then my C, look at your third number. Does 2 round things up? No, so it's going to be negative 4.75. So there's my A, B, and C. So we're going to write our equation. Y equal A x squared plus bx plus c, but c is a negative, so am I going to put a plus? No. And there we go. We good? Okay. Put your notes away, and we are done with notes for today.